Hi everyone. So today in this lesson we are going to be going over how to factor quadratics, so trinomials, when we have a negative c value, so when c is less than 0. There are two essential components to solving quadratics in this format. First, the quadratic should be in standard form, and second, c should be less than 0 where c is negative. So the technique we are going to be using to factor quadratics with a negative c is factoring by grouping. You're probably familiar with factoring by grouping, and if not, I highly encourage you to first learn this concept before trying to tackle negative c values. But I'm going to give you a slight refresher on how to do factoring by grouping. So traditionally, factoring by grouping involves a quadratic in standard form, and I'm going to change the color of the b value here, where we essentially split this middle value. So ax squared plus bx plus c is ax squared plus dx plus ex plus c. And remember, it's the factors of a times c that equal b become d and e. What we're going to do when we have a negative c value, so when c is less than 0, we are going to have the same standard form plus bx, except it will be a minus c, and we'll have ax squared, same thing, plus dx plus ex minus c. So this minus c component is what makes this lesson unique compared to factoring other types of quadratics, because typically we've seen where c is positive, but here c is negative. And it is going to slightly change the way we tackle these equations by adding one tiny little component. So let's walk through an example problem together. Example number 1. I promise you it will make a little bit more sense. So we are going to factor the quadratic equation x squared minus 3x minus 10. So this is what we're seeing here, this negative c value where c is less than 0. And so our first step is to figure out, is this in standard form? It is. And our second step, is c less than 0? It is. So now we're going to factor by grouping. So I'm going to rewrite this equation here. Oops. X squared minus 3x, oops, minus 10. We're going to continue as normal. So we're looking for factors of a times c, so that's 1 times negative 10, that add to negative 3. So let's list out the factors of, this is equal to negative 10. Let's list out the factors of negative 10. We have negative 1 and 10. We have positive 1 and negative 10. We have negative 2 and 5. We have negative 5 and positive 2. So what if we were to add them? What if I were to go in, erase these commas, and what if I were to add these factors? Well, negative 1 plus 10 is positive 9. 1 minus 10 is negative 9. Negative 2 plus 5 is positive 3. And negative 5 plus 2 is negative 3. So we can see here that this last pair of factors, negative 5, positive 2, are the factors of 1 and negative 10 that add to negative 3. So that means on this side, this is equal to x squared minus 5x plus 2x minus 10. So let's take a step back. What did we do that was different here? How is this different from every other type of quadratic that we have tried to solve? The difference is that we were looking for, I'm going to highlight it for you, this -3. Before, c used to be positive. So the values we were looking for here were positive values. But here, in this example, the factors we're looking for need to sum to a negative value. So it's a small change, but it's an important change. And so when we're looking at this -10 here, when we're looking at this -10 here, we have to be mindful of the fact that it's a negative number. And that is really, really important when we're factoring this equation. And so now we're going to factor by grouping as normal given this new set, this new equation. And so from this side, we're going to pull out a factor of x, and we're going to be left with x minus 5. And on this side, we're going to pull out a factor of 2. We're going to be left with x minus 5. And so then we're going to remove this x minus 5, factor out this x minus 5, and we're left with x plus 2. And so this is the factor, this is our example problem number 1 factored. x² minus 3x minus 10 is equal to x minus 5 times x plus 2. And as always, what is a good way to double check this? To find the product of these two binomials, to find the product of this pair of factors, and to make sure that when we FOIL it out or we use tables to multiply, it equals our original expression. So we're going to do that here. So let's try it. X minus 5, I'm going to write here, double check, so we know what's happening. X minus 5 times x plus 2. So how do we FOIL this? We're going to multiply this and that. We're going to multiply that and that. So x times x is x². X times positive 2 is positive 2x. Negative 5 times x is negative 5x. And negative 5 times positive 2 is negative 10. And so we're going to be left with x². Positive 2 minus 5 is negative 3x minus 10. Remember, all you're doing is combining like terms. And there we have it. This is our original equation. Boom. It's correct. Let's do one more example, this time with a positive b value. So let's go down to example number 2. Factor the following quadratic. x² plus 3x minus 18. So again, here we're seeing, I'm going to highlight it for you, a negative c value, but different from the previous example, we are seeing a positive b value. B is greater than 0. So again, it's not really something that's going to change the way you're factoring. You're still going to factor by grouping. But the difference is that these are just signs for the numbers and the coefficients that you are going to have to be mindful of, especially when you're finding factors and finding sums. So I'm going to walk you through this one again, but if this is something that you feel empowered to solve on your own, feel free to pause me, try it on your own, and then come back. So I'm going to rewrite this equation here, or rewrite this expression here. x² plus 3x² minus 18. Remember, we are looking, just like before, what we were doing, we are looking for factors of a times c, so positive 1 times negative 18, that add to positive 3. So we know that positive 1 times negative 18 is negative 18. So what are your factors of negative 18? We'll have negative 1 and 18. We'll have positive 1 and negative 18. We'll have negative 3 and positive 6. We're going to have positive 3 and negative 6. We'll have negative 2 and positive 9. We'll have positive 2 and negative 9. And I think that covers everything. Just like before, we are going to find the sums of all of these values, because again, we're looking for factors of negative 18 that add to positive 3. So negative 1 plus 18 is 17. Positive 1 minus 18 is negative 17. Negative 3 plus 6 is positive 3. Positive 3 minus 6 is negative 3. Minus 2 plus 9 is positive 7. And positive 2 minus 9 is negative 7. So we can see here that this set of factors, negative 3 and positive 6, equal positive 3. So the factors of 1 and negative 18 are negative 3 and positive 6 that add to a positive 3. So let's plug that back into our original expression, or not plug in, but we're going to split up this b value. We're left with x squared minus 3x plus 6x minus 18. Incredible. And so we're going to factor as usual. We're going to factor out an x. So we're left with x minus 3. Here we're going to factor out a positive 6. So we're left with x minus 3. We're going to factor out this x minus 3. So we're left with x plus 6. And there we have it. We factored the quadratic x squared plus 3x minus 18 into the factors, the binomials x minus 3 and x plus 6. And just like we did before, we want to double check our answers. So we're going to double check per usual. We're going to use our FOIL method. So x minus 3, x plus 6. Obviously, we're going to FOIL, multiply the x times the x, and then the x plus 6, and do the same thing for the second terms. So this is going to equal x times x is x squared. X times positive 6 is plus 6x. Negative 3 times x is negative 3x. Negative 3 times 6 is negative 18. Combining like terms, x squared, 6 minus 3 is positive 3x minus 18. And this looks like our original expression. So we know we got that right. So as you can see, essentially what we did was we factored by grouping as normal, but here we just had to be extra mindful of our positive and negative signs because c equals 0 here, or c is less than 0 here. C is a negative number.